Okay, here's another example of a conservation of momentum problem with a collision of two carts, the red and blue carts from Pasco that we occasionally use in class. Here you see the blue cart has a mass of 300 grams, is moving at 2.4 meters per second on a frictionless track. When it collides with a red cart of mass 5 kilograms, initially at rest. After the collision, the blue cart recoils at 0.95 meters per second. So here's kind of a before picture, with this one being the blue. So the velocity of the blue initials. That way, the velocity of the red initial is 0. And then an after picture, if we label this before the collision, after the collision, we'd have our red cart and our blue cart. The blue cart is going the opposite direction, recoils. So that's opposite this way. That's the velocity blue final. Velocity of red, it should be going to the left, I would imagine. Remember, there's momentum to the left at the beginning, so the total momentum at the end has to be left. This blue cart actually has some rightward momentum at the end. So likely this has to go left and has to go with a bigger momentum than the blue car had initially, right? Because it's taking away some of that momentum there. But let's now that we have these illustrations, we should be able to set up our equations pretty easily. So applying a conservation of momentum in the x direction, it's all in one straight line, so we can call that the x direction. The sum of the momentums initially in that x direction will equal the sum of the momentums finally in that x direction. We're ignoring any friction with the track, so there's no external forces. So before, we've got the momentum of the red one initial, and we've got the momentum of the blue one initial. That's going to equal the momentum of the red finally plus the momentum of the blue finally. There's two separate objects before, and after they hit each other, there's still two separate objects. Now, we're going to take this step by step. This would be the mass of the red, velocity of the red initial, and we would add to that the mass of the blue times the velocity of the blue initial. Here, the momentum of the red final, that's the mass of the red one, its velocity of the red one finally. A lot of subscripts, got to keep everything organized with red and blue, initial and final. So we took care of that red one finally. We have to account for the blue one finally. It has its mass and its velocity final. Now we can go in and substitute in some values. The red's mass is 5 kilograms. Now we have two different units of mass. We've got to keep them the same throughout. So we're going to change this blue cart to a kilogram. We're going to make the mass of the blue cart. That's 0.30 kilograms. So the red one, though, that's 5 kilograms times its velocity was 0 at the beginning, so that's going to go away. The blue one, it's got a mass of 0.3. Remember, again, we got to keep our units straight. They don't all have to be kilograms. They don't always have to be kilograms. They all have to match. So the velocity of the blue one initially we said is 2.4, and we got it going left in our illustration. Left is negative in our system, so I have a negative 2.4. Again, that's because it's left. We have right as positive, negative is left, is the convention we use in our class. So now the red one, its mass is 5. Its velocity final, we don't know. Velocity of the red final, that's what we're trying to find out. And then we have the mass of the blue cart, which is the 0.3 kilograms multiplied by its velocity. We know that it recoils at 0.95, so that's rightward. So that's a positive 0.95. Now, be careful, I put this little positive and minus there. That I'm not subtracting here, I'm multiplying. I'm not adding there, I'm still multiplying. So, we know that that one's 0, 5 times 0 is 0. 0.3 times 2.4, plug that in your calculator, and we get 0.72, that's a negative 0.72. That's the momentum at the beginning. This is 5 times VR final. We still don't know that. 0.3 times 0.95 is a positive 0.285. Little algebra, just subtract this from that side. And we see that the left now becomes 1.005 negative, and that's going to be 5 VRF. Now notice I had mentioned this earlier. Let me make sure we can see everything on the video. There we go. This is the momentum of the red cart after. Notice how it's greater than the momentum of the blue cart initially. And that's because it isn't that the momentum of one individual object has to stay the same or be bigger or smaller. It's that the group of objects, the system, has to have the same momentum. And since this blue cart bounces off, it has to give that red cart greater momentum than it had initially. Since it's taking some away, it has some oppositely directed momentum. And once we figure this out, solve for v there, divide both sides by 5, we'll get that the velocity of the red one final is...
Did I win?
Stop. 0.201 negative, which would be left. So it does go left at that speed. Say hello to Mr. McCauley.